All right, so first note card is number 5, and the title is Triangle Inequality. So we've had equations, right? And that's a math sentence that has an equal sign in it. But today we're going to have an inequality. That means it doesn't have an equal sign in it. So it has a greater than or less than. All right, so the sentence is the sum of the lengths of any two sides of a triangle must be greater than the third side. The sum of the lengths of any two sides of a triangle must be greater than the third side. And I'm telling you that's true, but let me convince you why. So let's say you had a really long, like maybe a 12-inch length. And then you had another side that was only 5 inches, and then a third side that was only 2 inches. That wouldn't make a triangle because these two sides are not long enough to reach to this other point. Okay, so in order to make a triangle, these two sides added up has to be bigger than the third side. So that's what this says. The sum, so added up, of the lengths of any two sides of a triangle must be bigger than the third side. And the reason why is if it wasn't big enough, it wouldn't reach to make a triangle. Okay, I'll show you more of that later. It also turns out that the longest side of a triangle is always across from the largest angle. The longest side of a triangle is always across from the largest angle. And then also the shortest side of a triangle is always across from the smallest angle. Shortest side of a triangle is always across from the smallest angle. Okay, that's everything that goes on number 5. So now go to the other note card. And of course that one's number 6. And try to remember to put your name on these note cards every time in case you drop them somewhere. I'll be able to get it back to you. This title is the Pythagorean Theorem. So I think you've heard of the Pythagorean Theorem before. what kind of triangles does the Pythagorean theorem work on? Can you use it on any triangle? It turns out it only works on a triangle that has a 90-degree angle. It only works on a right triangle. So here's the picture. In order for the Pythagorean theorem to work, the triangle has to have a 90-degree angle. Yeah?
You want us to draw the triangle with you?
It would probably help if,
Okay.
because some people sometimes accidentally use this theorem on triangles that don't have a 90-degree angle. And if you have this picture, that might jog your memory. Hey, oh yeah, I can't use it unless it has a 90.
Okay.
Yep. Okay, so just a reminder about the vocabulary. The side across from the 90 is called the hypotenuse. And the other two sides are called legs. So that's just terminology for a right triangle. It has two legs and a hypotenuse. And sometimes, instead of calling them legs and hypotenuse, sometimes we call them A and B and C. So often C stands for the hypotenuse, and often A and B stand for the legs. Notice I turned the triangle. This time the 90 is here. It could be turned any which way. The side across from the 90 is the hypotenuse. So C is the hypotenuse in this picture. And then, of course, this is the hypotenuse in this picture. Okay, so the Pythagorean theorem, there's two ways to say it. First of all, you could say legs squared plus legs squared equals hypotenuse squared. Or sometimes instead, you say A squared plus B squared equals C squared. Okay, so that's it for the note cards. So make sure you get those organized. Put them in your binder in your ring. And then you also need a sheet of paper for today's work. So the title for today's work is Triangle Sides and Pythagorean Theorem. So the title is Triangle Sides and Pythagorean Theorem. And in number one, they gave us three numbers, 4 and 6 and 7. And the directions say, is it possible to make a triangle that have these three side lengths? So if we had a 4-inch side, and a 6-inch side, and a 7-inch side. The question is, would it be possible to make a triangle out of this? What do you think?
No.
Okay, why do you say no?
Because the side just won't be long enough to.
Okay, so Charlie is on the right track because he's saying the sides have to be long enough to reach, like in this picture, right? This picture wouldn't work because the two sides are not long enough to reach. So he's on the right track. He's thinking about how long the sides are. Okay, yes. What's your name? Okay, Donovan, what do you got? So you're saying the 6 and the 7 are too long to go with the 4. Okay, so good. Again, we're thinking about side lengths. That's what we should be thinking about, right? How long the sides are to see if they would reach. Okay, it turns out no is not the right answer, though. It turns out they're okay. Why, Jennifer?
7's the longest side and 4 is our side.
So if you had a 7-inch side and a 4 and a 6, it would reach. And the reason why is, the key is this sentence right here. The sum of the lengths of any two sides have to be bigger than the third side. So what has to happen is this side plus that side has to be bigger than this side. Okay, so if you take 4 plus 6, we're going to investigate to see if that's bigger than 7. And 4 plus 6 is 10. And that is bigger than 7. So that's good news. So I'm going to put a check by that. And then we'd have to check the other ones too. Like 6 plus 7, we're going to see if that's bigger than 4. And 6 plus 7 is 13. And 13 is bigger than 4. So we're going to put a check by that because that's good news. We need the two sides added up to be bigger than the third side. And there's one more pair to check. 4 and 7, we need to see if that's bigger than 6. And 4 and 7 add up to 11. And that is bigger than 6. So we're all good. Okay, so the answer is yes. These three side lengths, so if we had a 4-inch piece, a 6-inch piece, and a 7-inch piece, they could connect to form a triangle. It would reach. And the way you check is you have to see if any two sides added up is bigger than the third side. All right, so how about these three numbers? What if you had 2 and 3 and 5? So again, the question is it possible to make a triangle that has these three side lengths? All right, Charlie?
No, because 2 plus 3 equals 5. That's not going to be.
Good. So we're going to investigate and see if this is true. We're going to add up two of the sides and see if it's bigger than the third side. And so I wrote this down even though it's not true because that's what we're investigating, right? So 2 plus 3 is 5. And then the question is 5 bigger than 5? And the answer is no. So I'll put an X by that saying, hey, this is bad news. It's not working out. So the answer is no. These would not make a triangle. And just so you can see what would happen, if you had a 5-inch side and then a 2-inch side and a 3-inch side, the 2 and the 3 would reach to the other side of the 5, but there wouldn't be any extra space for this to like go up and make a triangle. It would just barely reach to the other side. So even though it would reach, it would just make a flat line. It wouldn't make a triangle. Okay, so those three side lengths will not make a triangle. Okay, how about 2, 3, and 8? What do you think about that? Yeah, Maddie?
No, it doesn't.
Good. So just explain why. Like, what am I going to write down?
Because 2 plus 3 is 6, which is less than
Awesome. So you investigate, and you see, is 2 plus 3 bigger than 8? And Maddie's exactly right. 2 plus 3 is actually 5, but she's right. It's not bigger than 8. No big deal. So that turns out.
Sorry, I don't know why I said
I don't know why. I think you were thinking times, yeah. A lot of times people accidentally multiply. But you have the logic correct, so don't worry about it. So 5 is bigger than 8 is not true. So we put an X there. So that means the answer is no. And just to nail this home, the reason why is if you had an 8-inch side and then a 2-inch side and a 3-inch side, it's not going to be long enough to reach over here and form a triangle. So that's why it's not going to make a triangle. Okay, let's see. Next one I would like to do is number 4. And this time the question is, find the length of the missing side. So what kind of a triangle is this? When it's got a little square in the corner, that means there's a 90-degree angle. Yeah, Alex, wait. It's a right triangle. Good. So since this is a right triangle, we're allowed to use the Pythagorean theorem. Okay, so a lot of times people misuse the Pythagorean theorem, but you're allowed to use it when you have a right triangle. So here we've got a right triangle, so Pythagorean theorem is good. We're supposed to find this side. What is this side called? Yes, Yanni? Say that again? You're thinking it's going to come out to 7? Okay. It turns out it's a little shorter than 7. And the reason why is if you go this way and then that way, it's going to be shorter to go directly there. Like let's say I'm in the room and I start here and I go to that corner and then I go to that corner. Wouldn't it be quicker and shorter to just go diagonally? I'm not worried about what is the correct answer. What I'm worried about is convincing you that this would be quicker than going cornerwise. Good. So that's why it's not 7. But what you said, actually, a lot of people think is that you could just add these and get that. So that's a good contribution. Thanks for being willing to say that. Okay, so you're actually right with your second answer. This turns out to be 5. And the way you can figure that out is you take leg squared plus leg squared, and you equal it to the hypotenuse squared. I don't know what that other side is, so I'll just call it x. Mathematicians are really unoriginal. A lot of times they just call the missing side x. You could call it h for hypotenuse if you wanted, or c if you wanted to use a c for the hypotenuse. Yeah, it's going to come out to 5, that's right. So when you take 3 squared, you get 9. When you take 4 squared, you get 16. So I'm just squaring down. And then 9 plus 16 is 25. So try to keep your work organized. Try to work down. So I'm going to recopy that equal sign. I'm going to recopy that x squared. And then to solve, you take the square root. And actually, when you take a square root, you get 2 answers, right? Both 5 and negative 5. Sometimes people forget to do that, so I want to mention it. Now, in this problem, x is representing the length of the side of a triangle. And so negative 5 doesn't really make sense. Only in some bizarro world would there be a negative 5. So on this problem, you can cross that out. But on other problems that don't have a context, make sure you get 2 answers for this type of a square root. Okay, so on that problem, we were looking for the hypotenuse. Here's the next one. This is number 5. So we have another right triangle, which is good news because we'll be able to use the Pythagorean theorem. And again, the directions say, find the length of the missing side. Okay, now this one's a little bit trickier because they gave us the hypotenuse. So that one goes by itself. So you do equals 15 squared. On the last problem, we didn't know the hypotenuse. So that's why we put x squared. But on this one, we know the hypotenuse, so we're putting 15 squared. And then what we don't know is the legs. So, well, we know one of the legs, it's 2. And then the other leg is, we'll call it x, I guess. So notice the difference between number 4 and number 5. In number 5, the unknown goes here, but in number 4, the unknown went there, because that's the hypotenuse. So over there, x was the hypotenuse. Over here, 15 is the hypotenuse, across from the 90. Okay, so then you square everything out. 2 squared is 4. 15 squared is 225. And it would be really good if you could get into the habit of working down. So 4, 225. So then you subtract 4 to get rid of that. And then to get rid of the square, you square root. So I heard some people pulling out their calculators, which is good because I don't know what the square root of 221 is.
14.866.
Yeah, and how many numbers were there? Like, you don't have to tell me, just a lot, right? Did it fill up your entire screen? Yeah. Okay, so what the point I'm trying to make is, when you take the square root of this, you get this huge, nasty number, 14.668. I don't know what the numbers are, but they keep going on and on and on. That would be a big pain to write. So what I want you to write instead is just square root 221 for your final answer. And the way the directions put that is, leave your answer with a radical. This symbol is a radical. So number 4, the answer came out to a nice answer. It was 5, so we went ahead and put the answer. But this one, the answer is a big, long, nasty decimal. So we're just going to leave it like that. We can figure it out. It's about 14. But that is such a long number, it's better to write this. Okay, so that's 1 through 5. Now we're going to skip to a different concept. And this is called Pythagorean triples. So you don't have to write these formulas down, but we're going to have them up here for reference. So again, don't write these down. Okay, so what we're going to do, this is actually number 12, is we're going to find 3 numbers. And the 3 numbers we're going to find are going to make a right triangle. For example, on number 4, the lengths 3, 4, and 5 make a right triangle. If you were to measure out a 3-inch side, a 4-inch side, and a 5-inch side, it would make a right triangle. So because it makes a right triangle, it's called a Pythagorean triple. Okay, so what we're doing in number 12 is we're finding a set of 3 numbers that would form a right triangle. So that's called a Pythagorean triple. And you can use this to find them. So we're just going to pick a number for n, and it doesn't matter what you pick. So I'm just going to pick 4 for n and 3 for m. So this, you don't need to write the formulas down, but write this down. All right, so now I'm going to plug that into this formula. So I'm going to take n squared minus m squared. And that's 16 minus 9, which is 7. So my first number is 7. Okay, now I'm going to find my next number. And my next number is 2 times n times m. So I'm just plugging into this formula. And 2 times 4 is 8, and 8 times 3 is 24. So my second number is 24. Okay, now for my third number, we're calling that C, and that's n squared plus m squared. So that would be 16 plus 9, which is 25. Okay, so now I've got three numbers. They are 7 and 24 and 25. It turns out that if you measured this out, if you had one side that was 7 inches, another side that was 24 inches, and a third side that was 25 inches, it would make a triangle, but also it would make a right triangle. So that's called a Pythagorean triple, because these three side lengths make a triangle that happens to have a 90-degree angle. Okay, so we found a Pythagorean triple. Okay, so now we're going to find one more Pythagorean triple. So last time we picked n equal 4 and m equal 3. It doesn't matter what you pick. What should I pick this time? Okay, so n has to be the bigger one. So 6 for n. It's number 12. Yeah, so number 12 says, I think it says find a total of 5 Pythagorean triples. We've got one, and we're going to do another. And then I'm going to have you do some on your own. All right, and like I said, it doesn't matter what you pick for n and m. Okay, so Charlie picked 6 and 5. So for A, you do n squared minus m squared. So that's 36 minus 25, which is 11. And then for B, you take 2 times n times m. Just multiply all that out, comes out to 60. And then for C, you take n squared plus m squared. And that's 36 plus 25, which is 61. That's right.
Yeah.
Thank you. Okay, so now we got three numbers, 11 and 60 and 61. So what are these three numbers called? Yes, sir.
The
You got it.
Pythagorean triple.
Good. They're called a Pythagorean triple. And what does that do for you? What do these three numbers make? Yes, sir. A right triangle. So if we measured out 11 inches and 60 inches and 61 inches, it would make a triangle that had a 90-degree angle. That's why it's called a Pythagorean triple. Okay, now going all the way back to the beginning of class. How could we verify if this even made a triangle at all? Yeah.
Adding them up and seeing if 2 sides equal the third side.
You're 99% correct. You said if the two sides equal the third side.
Oh, no. Like more of it.
Good. So
Greater.
that's awesome. Yeah, so you add up these two sides and make sure that they're bigger than the third side. And then that tells you that it makes a triangle. And then sometimes it makes a special triangle that has a 90-degree angle. And in that case, the three numbers are called a Pythagorean triple. All right. Thank you for listening. I'll pass